Hey everyone. So, in this video, I'm going to be talking about doing an input tune on a Texas Star. But first, let me tell you why I'm doing an input tune on a Texas Star. So, if you saw my last video, I had this amp, and where is that radio? And this radio, I had those up on the bench. I was messing with them and getting them all tested, and the final kinks worked out. And shortly after that video, I took the Texas Star and the radio, and I put them into my truck, and had some weird results for sure. So basically, what was happening is that every time I would key up, the antenna light on the radio, so this light right here, that light would start to flash. It would start to blink red, and I couldn't figure out why, but I kept using it. And I took it for a drive, started driving around, and I figured I'd talk to my neighbors or whatever. So I key up, I start talking, and they're like, hey man, your radio's busted, basically. And I'm like, well, what's wrong with it? And it's like, you sound like you're off frequency, or you sound like you're on sideband. So sure enough, I come back from my drive, and I listen to a recording. So before I left, I put my base station on record, and it sounded pretty funky. I might splice that audio into this video just so you guys can hear it, but yeah, we'll see. So I got home and I listened to the audio and it sounded all jacked up, and I'm like, man, why is my radio doing this? It was working fine on the bench. I talked to people. I did a recording. The audio wasn't exactly what I wanted it to be just because of the filter that I put into the radio, but other than that, it was working fine. There was no issues. The little red light for the antenna wasn't coming on. So anyway, I went out to my truck and I started just shotgun checking things. I started checking jumpers. I tried different jumpers. I tried different connections. I checked all my grounds. I checked all my swerves. I checked everything I possibly could. And basically, what it comes down to is with this in line and turned on, I was having that issue. With this in line turned off, no issue. With this out of line, no issue. With this connected to a dummy load, in line and turned on, I was having the same issue. So even with this connected to a dummy load, it was still doing the same thing. And I sat there and I thought about it, and I figured, all right, let me take it back to the bench. I'll check it out. I'll see what's going on. So I noticed earlier that when I plugged it in at the bench, it had a so-so input tune. It was about an SWR of about 1.5. So I brought it back over here, I played with it, and sure enough, once again, it tested about 1.5 SWR, and I think that's what I'm going to tackle. I think that's my issue. That's the most likely candidate that I have right now for causing this issue. Now, I don't know for sure if that's the issue, but I'm going to fix it, and we're going to see. I'm going to fix that input tune. Now, I wanted to do a video on this because tuning anything in an amplifier is pretty freaking complicated. There's a lot of AC theory, there's impedances, you got to have the right tools, you got to have a VNA, not for everything, but for a lot of different things in an amplifier, it takes a lot of theory, a lot of knowledge, and a good set of tools. So I actually started making this video yesterday, and I sat here and I dicked around with it. And this is kind of my first go-around of tuning the input on a Texas Star. So it was a learning experience for me. I started making a video, I got halfway through it, and I realized I was going about it all the way wrong. So I took a step back, I sat down, I said to myself, what's wrong here? What's wrong with my measurement methodology? What's wrong with my testing setup? And I think I've come to a conclusion. And I'm going to show you the way that what I've done to actually fix this. So it's not fixed yet, but it will be. And hopefully I won't have to do this video over again because I screwed it up again, but we will see. So let me give you a breakdown of what I've done so far. So basically, this amplifier was working fine on the bench, all except for the fact that it had a bad input tune. It does not have a bad pass-through tune. The pass-through tune is almost perfect. Only the input tune. So when you key the amplifier on, you feed power into it and you make some power out. That's when you get the 1.5 SWR. You hit the power switch, key up, it's a perfect tune. My antenna analyzer agrees. The pass-through tune is perfect. So basically what my thought process is, okay, when my radio signal comes into this amp, it goes one of two ways. It goes through the relay and back out the other side. That's our pass-through tune. Or if we key the amp, we turn the amp on, it goes through the relay, through a bunch of switches, and then into the amplifier circuit. So just by knowing that the pass-through tune is good, tells me that whatever the issue is, it's on the amplifier side of the relay, not the pass-through side of the relay. So let's take a look at the schematic here real quick. And let's ignore some of my notes because these turned out to be a mistake. These turned out to be a mistake. And these turned out to be a mistake. So, now that we have that out of the way, let's take a look at the schematic and see where our RF actually flows through. So this is our radio input. The first thing that it does is it comes in through a piece of RG8. In my case, RG400. And it cruises up here and touches this this small capacitor right here. Now this small capacitor is for the keying circuit. So a little bit of RF comes through there. It triggers this transistor right here, which in turn turns on the relay, clicks you over, and kicks your amp on. So our pass-through tune is good. This is always connected to the signal. If our pass-through tune was not good, then this would be a candidate for taking a look at. But our pass-through tune is good, so it's safe to assume that there's nothing wrong with this capacitor. After that, our radio signal goes into this capacitor here, this 1000 puff capacitor. And kind of the same situation. If our pass-through tune was bad, we could take a look at this one and see if there's an issue there. But our pass-through tune is good. This capacitor is always connected, so it's safe to assume that this capacitor is going to be okay. All right. So this relay right here is our transfer relay, or our transmit-receive relay, and the pass-through tune is what's shown here, or the pass-through path is what's shown here. So it kind of zigzags around, comes back around, and then goes out through our antenna connector here. But when we key on the amp, the signal goes through, I'm sorry, I'm trying to do this through a cell phone, and it goes through here, goes through a couple of switches, and eventually it makes its way over here. So this is the attenuator pad. So this 75 ohm resistor and this variable resistor here, those are our, it's not really a pad, it's a voltage divider. If you watch BBI, he talks about that all the time. It's true. It's a voltage divider, not a pad. So we have a few different components that we can consider in our issues here. We've got the switches. Our RF signal goes through a couple of switches. If the dial-a-watt is turned on, these resistors come into play. If the dial-a-watt is turned off, these resistors do not come into play. After the pad, the switching, it goes through this piece of RG58 and over here to the input splitter. Okay, so on my radio I've got RG400 instead of RG58, but we have to consider all of the different parts in the schematic that come after this relay, because we know that our signal problem is after this relay. It's not before, because everything before is connected through the pass-through tune. So something after this relay is causing an issue. Now, I don't know if it was built this way. I have a hunch that this amp came this way. When I got this Texas Star, it's almost completely untouched. There's a few things in here that I can see that somebody has been in. If you can see that capacitor right there, that one's been hacked in. That capacitor's been replaced. So there has been one or two things that were touched in here before I got it. After I got it, changed the chokes, changed the power wires, put in RG400. I made some changes, but nothing that would cause my input tune to go up that high. Now you might be saying, oh, you changed the coax. That could have changed your input tune. Not likely. This coax is so short, it hardly does anything to the signal at all. It doesn't rotate it around the Smith chart far enough to be of concern. So it's actually also very, very similar to RG58 electrically. So changing this coax, very, very unlikely that that's what messed up my input tune. Unfortunately, I didn't take a measurement when I first got the amp. But like I said, everything in here looks pretty untouched. This capacitor here, where I'm pointing with my pencil, that one is suspect. It may have been changed. Same thing over here on our input on our input transformers. They look a little suspect to me because they don't look like mica capacitors. They look like poly something, or I forget what kind of capacitors they look like, but they don't look like mica capacitors. And from my understanding, these input transformers should come with mica capacitors, and if Texas Star didn't put them there, then somebody else did. If Texas Star put them there, then I'm just going to leave them. So yesterday I went through and I tried some different things. I noticed there's a discrepancy between this amplifier and the schematic. So this schematic shows this input tune capacitor and or that input transformer capacitor and that transformer capacitor. It shows those as being 1500 puff. Well, the ones in this amp are 1200. So just out of curiosity and for sake of having a little experiment, I swapped them out with 1500 puff mica capacitors, and I experienced an oscillation in the amplifier and just shut it off immediately. It didn't hurt it. It was very, very low power, but there was a little bit of oscillation, a little weird stuff going on. Now that could have been for a variety of reasons. Changing those capacitors could have changed my input tune so badly that it threw the whole system out of resonance, or it could have caused some fundamental problem with the input circuit. I don't know. I'm not going to go into that. I'm going to leave it how it was. Just a little side note that I did check and try that. So as far as I can tell, everything in here is primo. Everything in here is working and functioning. Those capacitors, they're good. I can't find any issues. When I look at the scope, I'm not seeing harmonics. It's a spectrally very, very pure output. So I'm not seeing any obvious red flags as to why this amplifier was giving me issues in the Mobile. So the only thing I've found so far is the input tune, and that's what we're going to attack. So now that we've taken a look at the schematic, we have some things to check out, and the truth is I've already verified that everything here is functional. This capacitor is good, these resistors are good, everything's on point. So my conclusion is that this amplifier was shipped this way. Well, you know, I don't know if it was shipped this way, but this is the way that I received it, so we're going to assume it was shipped that way because it looked pretty untouched except for one single capacitor. Okay, so bottom line, our input tune's bad. We got to figure it out. We know where to look for broken or burnt out components. We've checked for broken and burnt out components. Everything looks good. So basically all we have to do now is just tune it. Just change some values, add a capacitor here, add an inductor there, and tune it. Now, here's the hard part. Where do we put capacitors? What value? Where do we put inductors? And what value? This is the hard part. This is where you need to understand your AC theory. I'm going to try and break down the process that I've gone through as simply as possible. And I think it's going to work out. I think this video is going to be very helpful for a lot of you. I think it's going to show you some things that most amp builders won't teach you. Not that I'm an amp builder. I am certainly not an amp builder, but my whole channel is about teaching you the stuff that I have learned because I wish somebody would have taught me and I didn't have to figure it out for myself. So, all yesterday, spent all day figuring out how to do this myself, and I'm going to walk you through each step that I made that was screwed up and each step that I made that was correct. Okay. So, first step. We've determined that we just need to fix the input tune. We've already gone over that nothing is broken. Now we have to figure out where we want to tune the circuit. Okay, so our radio comes in, goes through a couple capacitors, goes through a relay. We've determined that the problem is somewhere after the relay, so we probably have to tune somewhere after the relay. But where exactly? Do we tune right here? Do we tune after this switch? Do we tune by this resistor? Do we tune by this splitter? Where do we tune? Now, there's a couple of things we need to consider when we decide where in the circuit we want to tune. And that has to do with these variable resistors and this splitter. So, if we tune over here, we're changing the input tune going into these resistors. If we change over here, we're changing the load that these resistors are going to see. Now, it's kind of a tough decision on exactly where to put your input tune, but the bottom line is that this resistor divider network is not a pad. It's always going to have a poor SWR, unfortunately. When you kick on the dial-a-watt switch and you run your signal through this pad, you're going to have a bad SWR because this is not a true pad. It's just a voltage divider, and your input impedance is going to fluctuate because of that. As you change these resistors, your input impedance is going to stray away from 50 ohms. So, in my case, I don't care about the dial-a-watt. We can ignore the dial-a-watt altogether. I don't intend on using it. This is a high drive box. Why would I want to run my high drive signal through a chintzy little variable resistor and a little carbon film guy right there? I don't need the dial-a-watt. My radio has an adjustable dead key. I don't care about this. But from yesterday's experimentation, I found out that if I tune in a certain position on this amplifier, I won't affect that much. I won't make this situation any worse. So what I've decided to do is I've decided to tune over here by this capacitor. The way that I figured this out, it's pretty complicated. I made some mistakes along the way. So I'm not going to share that video, but I've determined that input tuning right here is where we need to go. So this is the input splitter. It's an inductive, it's basically a transformer, and it splits the signal from one RF feed out to two. Those two split off to the two pill sections. The two pill sections amplify. They come out the output transformer and then come back through a combiner, which is the exact same device as the splitter. Interesting how that works. So we bring our output combined. That output goes to a few other little circuits like the bias and a couple of things, and then boom, out comes the relay. Anyway, this is where we want to tune. So how do we determine what components we need to put in this area? Well, we need to measure. So here's the thing. You might think, well, if we need to measure the impedance, if we need to know what's going on here, we need a device that measures impedance, like a nano VNA or an antenna tuner or a legitimate VNA, you know, a $2,000 or $3,000 desktop model. The problem with all three of those solutions is that this is a small signal device. So, if we want to know the impedance going into this splitter, we have two options. We can measure it with a small signal, or we can measure it with a large signal. Now, the problem with measuring it with a small signal is that when we turn the amplifier on and we feed a small signal into it, that small signal is not enough to bias up the circuit so that it is in the linear region of operation. It's a really complicated subject, but basically the bottom line is if you want to measure the input tune on active devices, transistors are active devices, if you want to measure the input tune going into an active device, you have to do it with an appropriately sized large signal. So by large signal, I mean our 2-watt dead key, our 4-watt dead key, our 5-watt dead key. We have to feed that in, and we have to measure in situ what is going on with our phase angles and our voltages and all that stuff. So we have to actually measure what's going on with a large signal. The problem with using a small signal is that it's not enough to actually bring the transistors up into their operating point. The way Texas stars are made is they actually don't bias themselves until you feed a signal in, and then the power comes back through and biases up the amp. It's pretty cool, but pretty weird. So the problem with all that is I would love to measure with a large signal, but I don't have a device that's capable of measuring with a large signal. So I'm stuck with my nano VNA. So unfortunately, we can't just plug a nano VNA to the input of the amp, turn on the nano VNA, click over the amp, and get our reading. It doesn't work that way. So that's why there's an antenna tuner sitting on my desk. This antenna tuner is a passive device. So with active devices, the small signal reading and the large signal reading are going to be two different readings, no matter what. So, active devices do weird things. They don't respond the same to a small signal as they do with a large signal. This antenna tuner is completely passive. It consists of two capacitors, which is these two knobs, and an inductor, which is this knob. So it doesn't matter if we measure it with a small signal or a large signal. It's going to provide the same reading, the same change in impedance, whether we're using a small signal or a large signal. So what I've done here is, you can see I've got some things connected. So if we refer back to the schematic here, we've got our input resistors. These are our attenuation resistors, and then they go to a piece of coax. That piece of coax jumpers over to the splitter. So that piece of coax on the schematic is this one here. Now normally this end is connected right where that SMA connector is, and it goes straight into the splitter. So that's the normal function of the amplifier. Now I have to measure the impedance going into this splitter. So what I've done is I've inserted the antenna tuner between the splitter and the coax. So I've disconnected this coax and I've wired in the antenna tuner between the two. Now here's where things get interesting. If your measurement procedure here is not correct, you're going to get weird readings. You're going to get wrong readings, you're going to chase your tail, and you're going to have a nightmare of a time. So being familiar with how a network analyzer works is crucial. There's a YouTuber that he's a ham. He goes by the name of W0QE. I strongly suggest watching his videos on both SimSmith, Nano VNA, how to use a VNA, especially his video on the reference plane. Reference plane is very, very critical to getting accurate measurements so that you measure once, measure twice, cut once, and go home. And it works. Measure twice, cut once, and you're done. There's a lot of things that can go wrong here. I could spend an hour, 2 hours, 3 hours talking about all of them. But I strongly recommend you go over to W0QE. That's his call sign. That's his YouTube channel. Look it up. Thank me later. Okay. So, as I was saying, basically we've got the antenna tuner in between this piece of coax and the input splitter of the amp. Now, what I've done is I've keyed up my amp. Actually, let me rewind a little bit. Before I even plug this in, I hooked up the output of the antenna tuner to a dummy load, a 50 ohm dummy load, and I hooked my Nano VNA to the input. At that point, I tuned the antenna tuner so that it was basically a pass-through. The capacitors and the inductor are active, but it's 50 ohms on both sides. The antenna tuner is essentially just a buffer. So we're getting 50 ohms in, 50 ohms out. The antenna tuner is not changing the impedance. After I did that, that's when I connected it into the circuit and started checking SWRs and taking measurements. So once I got this hooked in, I keyed up my radio, keyed it up, and I took a look at my bird meter here. So when I first keyed up, I was getting about 0.3 watts reflected on, I think it was 5 watt dead key. So if I put a 5 watt dead key in, I was getting about 0.3 watts reflected power. At that point, I adjusted my antenna tuner until my reflected power was as low as possible. So I think I can key this up right now. No, I cannot key this up. Where can I get it? Okay, you're gonna have to take my word for it. The radio's not plugged in. But when I keyed this up, I was getting about 0.3 watts, and after adjusting the antenna tuner, I was getting 0 measurable reflect. This meter was not sensitive enough to detect any reflected power. The needle would absolutely stand still when keying up. So with a 5 watt carrier going forward, I'm getting effectively 0 reflected power, or at least such a small amount that I can't measure it. Now, here's the important part. Once you get that done, you have successfully used your antenna tuner to tune the input of your amp. All right, now we're getting somewhere. So we've successfully tuned it. Now all we have to do is figure out what this antenna tuner is doing to our signal and put that into the amp. So we don't need this big whole box to go in here to get our input tuned. We only need a couple of capacitors and maybe an inductor. You know, maybe one capacitor, maybe one inductor, maybe just a capacitor. We won't know until we take a measurement. So that's where I left off. That's where I was right when I clicked on this video. So after taking that measurement, your antenna tuner should stay where it is. You don't touch any of the knobs. You leave it all right where it's at. And you measure through the system backwards. So previously, when I was running the test, this piece of coax was connected to my radio. So that coax was connected to my radio, and it went to the, that piece of coax went through my meter, right here, into the input of the amp. So, radio, meter, amplifier. Now, my signal went through this relay, went through a few things, and then came out this coax. Out this coax, into the antenna tuner, through some ridiculously extra long cables, out the antenna tuner, and into the splitter. So let's think about this for a minute. This is where you have to be careful about what you do. This whole process is very sensitive. If you're not careful, if you take a measurement in the wrong spot, if your methodology is wrong, you're going to get the wrong measurement and you're going to be chasing your tail. So there's reasons why I've used SMA connectors. There's reasons why that one is soldered to the board. It's all very important. It has to do with reference plane. Again, W0QE. Look it up. Anyway, so after that was done, my antenna tuner was left as it is. This is the point that we want to measure here, right at this input splitter. So I disconnected this coax, and I connected it right up to my nano VNA. Well, this nano VNA is calibrated to have the reference plane at the end of this cable, so I jumpered it to the end of that cable. So basically what's going on is we're measuring backwards through the antenna tuner, backwards into the amp, through this coax, through that relay, through that cable, through that meter, and then back to our radio. But we can't measure the radio. The radio may not be 50 ohms. So I disconnected that and connected it to a 50 ohm dummy load. Now the tricky part here, there's a lot of tricky parts here. One of the tricky parts is that we have to activate the relay in order to get this measurement. So in order for us to measure back through the amplifier and back through the relay, we have to engage this relay without turning on this stuff. So with Texas Stars, that's actually very easy, coincidentally enough. So this relay, or I'm sorry, this Texas Star, I've used this jack here, and I've made it into a keying jack. So what this does is when I connect the positive and negative here, it turns on the amplifier. It clicks over the relay. I do that for all my amplifiers and all my radios. It's just something I do. But basically, we only need one wire to make this happen. So that white wire makes its way over here. And this is it right there. So this white wire is connected to that diode. It's connected to the anode side of that diode. So the right side of that diode is where this wire is connected. All we have to do is connect that side of the diode to ground, and that will click the relay on. Neat how that works. Let me see if I can do it here. So this cable is the other end of this cable. All we have to do, touch it to ground. So touching that to ground clicks on the amplifier. Bob's your uncle. We're able to take our measurement all the way back through the amplifier, back to our dummy load. And boom, we got our measurement. So I've taken some measurements with my nano VNA, and I probably should show you the measurements I'm getting, because it might help. Okay, so this is what we're getting without the relay clicked on. And this is what we're getting through the antenna tuner, back through the amp with the relay clicked on. So if you notice there, we're getting an SWR of about 1.77. Interesting. Okay, so this is the tune right here. 49.8 resistive load. J29 is our reactive load. So that's what we need to compensate. We need to compensate that reactance. Fortunately, that's pretty simple, and I think that can just be solved with a capacitor, but I'm going to go determine that here in a few minutes. Now, essentially the opposite of this is the number we're looking for. So the way that I hook this system up, I'm measuring backwards through the system, measuring backwards. So this antenna tuner is tuned for this. We're not measuring the input impedance here, we're measuring the output impedance of this antenna tuner. Now, if you know anything about AC theory, that means that this could be, for example, 50 ohms J5. For this to work with that, to be perfectly matched, this would have to be 50 ohms negative J negative 5. So this measurement here, if you noticed a minute ago, we got a positive number on our X component. We need to flip that number around to get the impedance going into this point. That's the conjugate impedance. Again, this is a complicated subject. I'm actually not that great at it. but I'm figuring it out, and here in a few minutes this amplifier is going to work, and that input tune is going to be flawless. So anyway, this is my process for tuning an amplifier. I'm going to take that impedance measurement, and I'm going to go figure out what capacitors and inductors I need. Now the way that I do that is I go into SimSmith. SimSmith is a really awesome program. I'm going to say it again, W0QE. Go to his YouTube channel, watch his SimSmith tutorials. They're super valuable. Anyway, I'm going to take that number, I'm going to pop it into SimSmith, and I'm going to design a matching network that will get me the proper impedance, and then we're going to come over here. Hopefully I'll have the right capacitors or inductors in my junk drawer. We'll slap them into the board, connect it up, and see what our reflected power is like. Now, yesterday I went through this process, but I screwed up my measurements. I took measurements in the wrong places. I put the wrong components in, and the SWR that I ended up with was worse. It was 2 to 1 instead of 1.5 to 1. So I'm going to go try this. We're going to see how it works, and this thing's going to be rocking and rolling. I'll be right back. We have success. So I took that impedance number that I found with my Nano VNA. I went over, punched it into SimSmith, and boom. All I needed was a series inductor. Just a series inductor of about 170 nanohenries. Pretty small inductor. Found a spot for it on the circuit board. Bam. So let me show you where I actually put the inductor. That's it there. So normally the center of this coax would be feeding straight over to this point here. Let me get my pointing device. So normally the center of the coax would be here, and the shield would be to ground. All I've done is I've put an inductor between the center of the coax and that point there. So this trace here, I don't know if you can see it, that trace just happens to be not connected to anything, so I was able to repurpose it for this usage. Connecting my center coax to that trace probably added some stray capacitance, but it wasn't enough to really make a big difference, and my reflected power is significantly better than it was before. So first let me put it in forward. Putting a 5-watt dead key in. That's a little excessive for this amp, but that's what I've been testing with. Alright, so we got a 5-watt dead key in forward. This is a 10-watt slug, by the way. Almost 0.1 watts reflected power, if that. That is significantly better than what it was before. Before, it was probably swinging up to this point. So what is that, 0.6 watts? Significantly worse SWR. So I haven't calculated what that is in SWR, but it's definitely better than 1.5. I might plug the meter in and check later, but for all intents and purposes, this tuning process was a success. 5 watts forward, 0.1 reflected. I'm happy with that. I'm quite happy with that. So obviously 5-watt dead key is too much. That's about a 200-watt carrier, which is it's too much for this. These Texas Stars, the 667Vs, the 500Vs, 200 watts is a little bit too much carrier. I generally run them down around 100 and let them swing. So that concludes a several-day project for me, and maybe a 40-minute video for you guys. I hope you learned something. I hope that something I did in this video taught you something that you didn't know before. I hope that if I made any mistakes in this video, you don't crucify me for it, because I don't do this for a living. I'm a hobbyist. I figured this stuff out. I'm just trying to share my experiences with the difficult topics. Like amp work is definitely a complex topic. I'm just trying to share my experiences with you guys so you don't have to find out the hard way like I did. But anyway, Mud Duck Sharky, and I'll be back with another video. Take care.